Hello everyone, welcome to Abdo channel. In today's video, we will discuss about data types that are available in Java programming language. Basically, a data type means the type of data we can store in a variable in a Java program. So we will see in this video what are the different types of data we can store in a variable that is declared in our Java class. Okay, so let us start with what are the different kinds of programming languages available when it comes to data types. Okay, so there are two kinds of programming languages: statically typed languages and the dynamically typed languages. Statically typed means the time you store data to a variable or you declare a variable, that time itself we have to specify the type of that variable. Say for example, in your Java program, we write a variable something x. Okay, while you are declaring that variable x, you have to strictly mention the type of that variable, whether it accepts the numbers, whether it accepts the characters, whether it accepts the strings. Okay, whether it accepts any fractional numbers that time. So while the declaration itself, you have to mention its type. That is called as statically typed languages. So examples of statically typed programming languages are C, C++, Java, etc. Okay. So there is another type, that is dynamically typed languages, which means that the type of variable will be identified at runtime or by the value that is assigned to it. Say for example, there are some programming languages like Python and Ruby where you don't have to mention the type of that variable. Say for example, you created a variable x. Okay, x is equal to 10. Okay, you assign x is equal to 10. So its type, if you get the type of that x now, it will be coming as integer data type or a number data type. But after the course of execution of that program, at later time you assign some string abdev to the same x. Okay, say for example. So now if you get that type of that x variable, then you will get it as a string. Okay, which means that for the same variable you are assigning different data types, but different data, but its type is being identified based on the data you assign to that variable or store in that variable. It is basically called as dynamically typed language. Okay, that is the difference between statically typed and the dynamically typed language. Let us go to the next topic. Okay, there are two kinds of data types available in Java programming language: primitive data types and the non-primitive data types. In this video, we will be covering mostly the primitive data types. Non-primitive data types, we will get the difference between primitive and non-primitive, but we will be covering a separate videos for each of these non-primitive data types. Okay. So first of all, let us understand what is a primitive data type and what is non-primitive data type. Okay. Primitive data type is a data type, okay, that is coming inbuilt with a programming language. Okay, there are some data types that are coming with Java program inbuilt, like to store numbers, to store floats, floating point numbers, to store characters, and to store Boolean data types, right? These all are coming along with the Java programming language inbuilt. So those are called as primitive data types. They'll have certain size limitations, like for integers, they will be having some certain size, and it will be having some range of values it will accept as the minimum number and maximum number. All those primitive numbers will be having some certain limitations. Okay, to store the data, what is the maximum value, what is the minimum value we can store. We will go through all those details. What is the max and min, what is the size, what is the different data types available under the primitive in this video. Okay, there is another thing, like there are some data types available in under primitive category, right? To store number, into data type, short data type. These are all called as uh, keywords in a programming language. Okay, int is there, short is there, byte is there, char is there, float, double, boolean. These are all the keywords. Okay. Well, we cannot call any methods on these primitive data types. Say for example, we have seen in our earlier videos, we have seen the class, right? Class is one of the non-primitive data types. Okay, in that video we have seen how to declare a class, how to declare the methods, what a class contains group of properties on the methods, right? uh, if you want to know more details about the class, I recommend you to go through that video. I'll be mentioning that video link in this video description so that you can go through that. That is one of the non-primitive data type, right? So in non-primitive data types, we will be having some methods, okay? But those methods you will not be having on the primitive data type, okay? So primitive data type is just a small integer constant just a constant value. You cannot or a literal value basically. So you cannot do any you cannot make any methods on that value. Okay, and they will be having some default value. What will be the default value for each of these data types? For primitive data types, each primitive data type will be having some default value if you don't assign any value to it. That also we'll see. Okay, coming to the non-primitive data types. Okay, as opposed to the primitive data types, right? Those are coming with inbuilt programming language, but non-primitive data types accept a string class, right? Accept a string. The remaining all won't come from programming language inbuilt. Class, interface, all those things we only have to create ourselves. The users or the developers have to create themselves. Okay, string is the only non-primitive data type, that is only one non-primitive data type, but it is given inbuilt with Java language. Okay, remaining all we only have to create, or the developers have to create. Non-primitive data types are called as reference data types as well, because reference means they'll be referring to some objects, like class will refer to some object, right? Methods can be called to do the further operations on non-primitive data types. Like as opposed to primitive data types, we won't be having any methods on the primitive data type literals, right? But we can call the methods that are available on string or class. Okay, so that is the difference between primitive and non-primitive data types. So let us start with going with the primitive data types. The first one is integer data types. Okay, integer data type is used to store the whole numbers. Okay, whole numbers means they will not be having any fractional part or the decimal point. Okay, it is just a normal number. Okay, I mean we can store any positive or negative numbers without any decimals. Those are called as integer data types. So if you refer, there are four kinds of integer data types here. Okay, byte is there, byte, short, int, long, and this is the memory size for each of these data types. If you want to store very short numbers, like -128 to 127, right? Then you have to use byte. If you want to store some uh, less numbers, right? 2 byte, then you can use short, int, and long. Long will be occupying 8 bytes. Okay, we will get to know how we come to this min and max values. We will discuss in detail. Okay, see, this byte data type is occupying 1 byte of data, right? This 1 byte means 8 bits. Okay, so any data in computer systems stored as a binary number, right? Like zeros and ones. So we use two's complement system to represent those binary numbers. 2's complement means 2 to the power of 1, 2 square, 2 cube. That is called as 2's complement. So here we are having 8 bits. 8 bits is equal to 1 byte, right? So 2 to the power of 8 means 256 different values we can store. Okay. What are those 256 values? I mean, they can be either positive or negative values, because byte will, all these integer data types will accept the byte uh, positive and negative values, right? So 256 positive and negative values we can store. But what is the value range for positive and negative values? Okay. Uh, Among these 8 bits, I mean, system takes 1 bit for storing the size. So 7 bits will be there. So in the remaining 7 bits, the data will be stored. In the first bit, in the most recent bit, right? That will be having the sign of that number. Remaining 7 bits, so data will be stored. So 2 to the power of 7 means 128. So as we have to store 0 also, it can store 0 to 127. So 128 different values, positive values can be stored. So 0 to 127 positive values can be stored. That is 2 power 7 minus 1. Okay. That is the maximum value. What about the minimum values? So 2 power 7. The 0 we are calculating it here itself, right? So 2 power 7 will be the minimum value for your negative values that you can store in byte data type. That is minus 128. So minus 128 to 127 is the min max values you can store in a byte data type. That is about the description about min and max values, how we calculate the min and max values for any data type. As we know, primitive data types will be having some default value, right? That is 0 for this byte. Okay, if we don't assign any data to the byte variable, then it will be having 0 by default. Now let us understand this with an example. Okay, let us go to data types. Let me create a class data types. Let me create my main method. I'm going to instantiate. Let me have a number or byte number, byte x. Okay, let me have one method in this class to that reads this variable. Okay, display number, public void display number, and it just prints that number, system dot out dot println of display number. We let us call that method. Okay, like this we can call, right? We can create an instance. On that instance we can call any instance method. Now let me open command prompt. Let me go the path. Let me compile it. Okay, display number. Yeah, this is not a display number, right? I have to print x here. See, I have not assigned any data to this byte variable, but it is giving me 0 because its default value is 0. Okay, now let me assign some number to it. Okay, some 110, 100. Okay, let me see if it gives me the value or not. Yeah, if I assign 1000 to it, what will happen? See, possibly a lossy conversion from int to byte. You are storing a number, but that is not in the allowed limit of your byte. You will be losing some data. You will be losing some data. That's what it is giving us, the compilation time error itself. So we cannot store any data that is more than 127, right? Let me add 128 then. It is still giving us the error. This is fine, right? It is allowing. So this is the maximum and minimum values that we can store in a byte data type. Okay, now let us go to the other data types. What is the next data type? This is short, right? Short accepts 2 bytes. So 2 power 16, right? 2 power 16 different values we can store. So 2 power 16 means one bit will be given to the sign. So 2 power 15 to minus 2 power 15 to 2 power 15 minus 1 are the range of min and max values. Similarly for int 4 bytes, okay, for long 8 bytes. These all are having some different default values also 0. Okay. Now let me try with this one short. Okay, short x is equal to 127, right? What is the minimum value? Minus 32768, maximum is 32767, right? Let me assign 32768 then here for short. So it is still giving because we are storing more than the accepted range maximum value. So this is about short, and int also same thing. But if I declare a long variable uh, which is of 8 bytes, right? See, long variable occupies 8 bytes of memory, right? So let me assign some value to it. Okay, I'm assigning and I'm printing it. Let me see what will happen here. Yeah, it is printing it, right? So there is no problem with storing data for this variable. But if we try to store a value that is more than the accepted value of int, see for this one, here it is in the range of int, the 32767, right? Let me take the value from here. Yeah, from where? Yeah, this is the value of integer maximum value, right? Let me add it here. Let me see what it does now. It is still accepting it, right? So as long as we are giving a value that is in the as long as we are giving a value that is in within the range of int data type and assigning it to the long, there is no problem. But this value, I'm incrementing it by 1. Now this value is not within the range of int. Now I'm assigning it to the long. Okay, now see what will happen. See this integer number too large. Okay, so it is still not treating it as long. By default, any number you store in a long variable, it is treated as integer. Okay, as long as it is within the range of integer. But if you want to store a value that is more than int data type, more than 4 bytes, but within less than 8 bytes within the long data type value, then you have to mention I am trying to store this value as long by specifying a constant or literal L at the end of that variable value. Then only it will be treated as long data. Otherwise, it will still be treated as int data type only, because by default it will be treated as int, because that value, whatever the value if you are storing, that will be within the range of int. If it is not falling within the range of int, then you have to mention it as a long variable explicitly by the L letter, L alphabet. Okay, so that is about declaring long variables. If you see this one, 2 powers for long variables 8 bytes, right? Min and max values is 2 power minus 2 power 63 2 minus 2 power 63 minus 1. for int data types minus 2 power 31 to 2 power 31 minus 1. Okay, that's about the different data types we have in integer data types category. Okay, let me go to float data types. So in float, we store numbers with decimal places or the fractional parts, right? Let me go here. Yeah. So numbers with decimal places and the fractional parts we store. I mean, we consider them as floating point numbers. So float data types there are two data types under float category: float and double. Okay, float is having 4 bytes and double is having 8 bytes. Okay, so maximum number of decimal places accepted is six fractional digits for float. As we can store fractional digits, right, in float data type, it stores up to 6 fractional digits. Okay. Similarly, there are some min and max values ranges also. 1.4e minus 45 to 3.4e 38 for positive values. For negative values, minus 3.4e 38 to minus 1.4e minus 45. See, this is a scientific notation of a bigger number and smaller numbers. If you want to define a number, very big numbers or very small numbers, we can use the scientific notation. Okay, this will be represented as like this: 1.4 into e minus 45 means 10 to the power of minus 45. Okay, similarly 3.4 e38 means 3.4 multiplied by 10 to the power of 38. That is the maximum value for positive values. Okay, that's about float data type. Let us see with an example. Okay, this will be having if we don't assign a value, that will be having a default value, right? Okay, let us see with an example. See here, float x is here. Now I'm not assigning anything to it. Okay, let us see what it will print. Yeah, so by default it is assigned with a default value 0.0. Now if I assign some integer value to it, what will happen? It is converted to float. So even if you assign integer data to a float variable, it will be converted to string. Okay, it will be converted to float. Sorry. So let me assign some number to it, some floating point number. If I assign some floating point number, see this incompatible types, possible lossy conversion from double to float, which means that this variable is being treated as double, but we are storing that in a float. So we should not be doing like that, right? So by default, like we have seen for integer data types, when it is coming to int and long, it is still being treated as int only, as long as you declare L at the end of that variable value. Similarly, here it is being treated as double. By default, the double data type is taken up and the 8 bytes will be allocated. But here, we have to, in order to store this as a float, we have to mention a constant literal f here. Okay, then only it will be treated as float variable. See, it is compiled, right? Similarly, it tells which means that 10.5f means it tells the JVM to declare this variable as float, not as double, and allocate only 4 bytes of memory to it. So if you don't mention it, it tries to allocate 8 bytes of memory and it will fail, because double you may be losing some data, right? Yeah. So that is about double data type. Let us take one more example. We have seen that it allows up to 6 fractional digits, right? Let us see what will happen. Uh, Let me add 4, 5, 6, 7. 7 fractional digits I added. See, it is accepting only 6. Okay. Let me add 5, 6, 7, 8, 9, 1, 6, right? Let me add 2. 891. So it is coming only 6 fractional digits. Even though you are giving more than 6, it will give only the 6. Okay. So that is about this one. Say for example, we have seen that we can use these floating point numbers to represent very big numbers also, right? Yeah. Say for example, I am giving this one, very big numbers and very small numbers also, right? I'm giving this one. Okay, I'm trying to store this uh, very small number, 0.000 something 14f. Let us see how it prints now. Okay, it should be converted to the scientific notation. Okay, it is floating point number too small. Okay, let us add. Let us see with this. Yeah. See this 1.4e minus 36. So this is the minimum value we can store. What is the minimum value? 1.4e 10 to the power of 45, right? 10 to the power of minus 45. Here we are seeing 1.4 multiplied by 10 to the power of minus 36. So this is somewhat near to the minimum value. Okay. Earlier we had given more zeros and it is even more, even the very small value. That's why it is not allocating. I mean, it is not accepting that much small value. So we remove some zeros in the fractional part. So it is somewhat near to the very small value that floating point number can accept it. Okay. So that's about floating point number. Okay. Now let us go to double. Okay. Double is having allocating 8 bytes of memory for any variable you declare with 8 bytes, right? Double. So it's a default type for floating point numbers. We have seen that with an example, right? It is allocating, it is trying to store that float value into double and we are losing some data. That's what the error it has shown. After that, we added a f literal to the float variable value so that it will be treated as the float only. So double is the default data type if you don't mention anything. Okay. Uh, it stores up to, it stores up to 15 fractional digits. Here, it is allocating 6 fractional digits, right? Uh, Double will accept it up to 15 fractional digits. Similarly, for the positive values, it is 4.9 multiplied by 10 to the power of minus 324. That is the minimum value of positive number it can accept. So, minus 4.9 multiplied by 10 to the power of minus 324. Okay, that is the minimum value. Similarly, for negative values, minus 1.8 into 10 to the power of 308. That is the minimum value for negative values. Minus 4.9 into 10 to the power of 324. That is the negative maximum value for the negative numbers. So that's about the float. The main difference is the double is the default data type. Float occupies 4 bytes and double occupies 8 bytes. And the difference is in the fractional digits it can store. Float accepts 6 fractional digits while double accepts 15 fractional digits. Okay, that's all about float data types available in Java programming language. Now let us go to char. Okay, character data type. Here, this is one point, right? We have seen Earlier, while we are talking about the primitive data types, those data types will be declared as uh, reserved keywords, keywords that are shipped with Java programming language. If you see here, this float is a keyword. You cannot have a variable name uh, with the reserved keywords, right? That's why it is not allowing here. So the primitive data types are the keywords in programming language. Okay, similarly for float and double, whatever it is. Okay, similarly let us go to char. Char is also it accepts 2 bytes of memory. Okay, we will come to this later on. Okay, what is the min and max values, what is the default value. Okay, char is used to represent a single character like this. let me represent Let me declare this character variable char x is equal to, like this we have to mention. If you mention within double quotes, let us see what will happen. Char x. Okay, I have to give semicolon. Incompatible types, a string cannot be converted to char. So if you are mentioning it in a double quotes, it is treating it as a string and it is trying to store it in the character variable, which is not allowed. So for character, you always have to mention in single quotes only. Okay, that is about representing or declaring a character. But in char data type in Java, right, and Java programming language is used to store the Unicode characters. That's why it occupies 2 bytes of memory. Let us see why char data type is having integer value range. Okay, see here, here the min and max values are 0 to 65535, right? So total 65536 values we can characters we can store. Why Java has to support 65536 characters storage? Because it supports different international languages characters and the mathematical symbols. Okay, there is, before the Unicode system there is another character encoding system, that is Ascii characters. So Ascii by default supports only 256 different characters. Some English, only the English language characters and some symbols that are there on any keyboard. Okay, only those can be converted to ASCII character codes, and they will be stored in the memory. But coming to Java programming language, as the main intention of the internationalization feature, uh, they wanted to support so many international languages along with the scientific symbols, mathematical symbols, and all. So that's why they want the increase. I mean, the char data type size is 2 bytes. Okay, and because it accepts all language characters that is coming from the Unicode system. Okay, so let us understand what is the difference. Why we are having the minimum integer value range for char data type, because any character we store in a char variable, right, that will be converted to its integer constant value, which is ASCII or the Unicode system code, and the integer value will be stored in memory. Okay, so for let's say for example, if we are storing here a, right, if I its value will, its ASCII code will be stored in the memory. If I want to get the ASCII code, I can convert that to the int and print. See, and its ASCII code is 97. So that's why the min and max values are given in the integer, even for the character variable. 65536 different characters, so we can store in a character data type variable. Okay, there is a slide which I have prepared to find the differences between ASCII and Unicode systems. So there, as I said earlier, right, ASCII is the old character encoding system that is supported by C and C++ languages, and it supports only the 256 characters, right? 0 to 255 different values are given to 256 different characters, and those characters will be can be represented within a 1 byte of memory. So that is about ASCII. But when it comes to Unicode, as it supports several different language characters and also the mathematical symbols, right? It supports up to 65536 different characters. So 650 to 65535 are the different Unicode character codes, and they will be stored in the memory when you store the Unicode character. Okay, that's about differences between ASCII and Unicode. Let us see some examples on the char data type. Okay, we have seen how to store a character into a variable, how to get the ASCII code of a character. Okay, now let us see if I mention like this, some 120. Okay, this is one integer number. I'm storing it in the char variable. Let us see how it goes now. See, it is compiled. So this is x, right? So x is the character that is given, whose ASCII code is 120. Okay, if I give 65, right, it should give the capital letter A. Yeah. So 65 to 90 are the ASCII codes for capital letters. 97 to 122 are the ASCII codes for small letters, right? So as we are printing, as we are assigning, even though the integer constant, it is converted and it is giving us the character. Okay, the respective character. Similarly, as we know, Java supports Unicode characters also, right? We can also give the Unicode characters. Okay, you can to an integer, to a character variable. Okay, slash u. Like this, we have to mention the any Unicode characters. We have to escape that with slash u and 0045. This is one of the Unicode. We'll see what it gives. Okay. See, this is the Unicode character for E, for character E, Unicode slash U0045. If I give 46, what gives F? Okay. So this is how we store Unicode character and we get the corresponding character, uh, Unicode data into a character variable, and we will get the corresponding character here. Okay, that's about representing or storing characters or Unicode characters or the numbers and getting the character from the character variable. Okay, now let's go to Boolean data types. So Boolean, right? Boolean is actually used to represent either true or false. Suppose if I write some conditions in any programming language, right? It will, if it is satisfied, it returns true, or if it is not satisfied, it returns false, right? So true and false will be the values, the the accepted values for the Boolean data type. This will be used whenever we are having some conditions, right? So 1 bit, I mean the memory size is 1 bit. Okay, at least it takes 1 bit because it has to store only uh, true and false corresponding data or the binary data in the memory, right? So it takes at least 1 bit, but the actual size is not defined by the as per the Java documentation. So it depends on the JVM implementation, but at least it takes 1 bit of memory. Okay, let us see with an example. Okay, if you don't give not byte, right, boolean status. Okay, let me print it. Let me compile, let me execute. Yeah, see, this is the false. So if you don't give any assign any value to the boolean variable, by default it will be assigned with false. Okay, now here uh, I'm assigning status is equal to 5 greater than 4. Okay, this condition will be evaluated now, and the expression evaluation result will be stored, whether it is a true or false will be stored in the status variable. Okay, this is how, see this, true, it is given 5 greater than 4, it will be evaluated to true. True will be stored in the status variable and we are printing it. This is how we assign data to any Boolean variable, and we can use it uh, in the conditional expressions. Okay, so like this, if of status, right, then only it will print, else we can mention some string, right, condition not satisfied. So, let us see this one. Okay, println condition satisfied, which means that this Boolean variable is having true. That's why it is printing this line. Now, if I change that condition not satisfied, this Boolean variable is having false. So this if condition is not satisfied, it is not true, right? So it is going into else and it is printing it. Okay, that is about Boolean data types. So that's about the different data types or the primitive data types which we have seen in today's video. We will be creating separate videos to know more details about arrays, strings, and interfaces. As we have already covered the class non-primitive data type. Okay, that's all for today's video. Thanks for watching. Please give it a like, share, and subscribe to my channel. Thank you.